Okay, hello DevOps. Welcome to this tools in action session about how to speed up our development workflow, how to gain in terms of productivity while working with containers in Java. So before diving into the slide, I want to just do a quick poll. So how many of you are using containers while working with Java, obviously in development mode, especially in development? Okay, so that's around 90%. And how many of you especially working with Kubernetes in development and not using other tools like Docker Compose? So that's only 10%. And for those of you, how is your development experience while working with Kubernetes and generally containers in development? It is improve your productivity? Okay, so that's kind of 0%. Yeah, so you are in the right room. So my talk basically will highlight how we can gain of terms of productivity while working with containers and mainly Kubernetes and Java, of course, and we'll highlight a tool called JIB and other tools that works with JIB, obviously. So if we look at our development workflow, typically, if you are working with any language, we can see that we can split it into four major phases. So the first one is introducing code and making changes to our code base, either by introducing a new feature or fixing a bug. So, and once we reach a certain satisfaction with our code, then we build our code to generate an artifact. And in the context of Java, obviously, we use either Maven or Gradle for that. And once we generate the artifact, we deploy it into an application server. With the rise of microservices frameworks like Spring Boot and Microroute and Vertex and so on, things got simplified, and we have like kind of embedded application server, and we simply run java-jar to start our application. And finally, we do some testing. And by testing here, I don't mean all like integration testing, unit testing, and so on. I simply mean the verification step, the things we do to verify that the code we write works according to expectations, like viewing the logs, calling our endpoint, like hitting the endpoint in Postman or opening a browser and checking the code that we introduced works according to our expectation. And containers came, and they changed the way we develop, architect, and deploy our application to become the executable of the cloud. However, containers don't necessarily make it, especially for development, easier. They added kind of layer of abstraction, making our typical workday look something like this. So for us, for a single verification, for a simple test, we need to do all these kind of steps to verify that the code we wrote is doing what it needed to do. So if we check like a small example here, I have a simple Spring Boot application. It's a simple hello world application that have two endpoints. The second one is a health check, and the first one returns a stream of hello world each 1 second. Easy peasy. And I have a Dockerfile here, and I'm using multi-stage build. And for those who are not familiar with the multi-stage build, I am simply, so multi-stage build is simply helps you to separate your build stage or stages from your production stage, keeping your production image clean without the unnecessary build dependencies. So I have two stages here. The first one is to build my image, and I'm copying the source, copying my POM file, and then building the image. And then in the production stage, I'm copying only my artifact into my production image and then starting the application. I have my Kubernetes config files here, so it's really simple, really basic. It contains only one replica to deploy my application and then some liveness probe and so on. So nothing fancy here. And if I need to verify that my application is working, I need first to, sorry, not this one, let's start with this one. I need first to build the application and generate an image. And I already generated the image, so this relatively need to be quick. After that, I need to deploy the application. I need to apply some changes into my Kubernetes cluster and deploy the application into my Kubernetes cluster. And for that, I use kubectl apply and specify the folder. And I need afterward to verify if the image, if my pod started and if my application running, and it's effectively running. And I do some testing to verify if the application is running, and it returns the good result. So what about if I introduce some modification? We are at DevOps, and all hello world application need to be, instead of hello world, need to be hello DevOps. So let's make this quick change. And then what we need to do is we need to redeploy the application. So for that, we need to rebuild our image. But this time, instead of running quickly, since it's introduced some changes, because of this false dependency between Docker layers, it needs to rebuild the application. So if I go back to my Dockerfile, you can see here that since I modified the code here, all the steps, because of this false dependency in Docker Builder, needs to be rebuilt and re-executed, which takes a lot of time. So let's go back to our slide. So those are all the steps that we need to do in order to verify that the code we modified works according to what was intended. And if we want to tag those images, those steps, and like categorize them, we end with 5 steps. So the first one is to build the image to generate the artifact, build our code, sorry, to generate the artifact. Then we containerize it, and that by I mean generating a Docker image. Then afterward, we push the generated image into a registry, and then we deploy it into our Kubernetes cluster or whatever your orchestration tool. And finally, we connect to verify that the code we wrote and if everything is working fine. But the thing is, all those 5 steps, all those 5 phases are not the things that interest the developers. What really excites us is simply introducing new changes, modifying our code, and verifying the results. And there is a nice post from James Ward 5 years back in 2014, who says that Java developers need to reduce the validation cycles. And the more time you spend waiting to verify your changes, the more time you waste, the more productivity you waste, and the more money you waste. So we need some way to improve productivity while working with containers. And the first step toward finding the solution is understanding the problem. So toward this talk, we'll verify, like for the 5 steps, we'll try to understand what are the problems and come up with a solution for them. So the first 2 steps are build and containerize. And there are a couple of issues while working with those. So I built my image using Docker. And I run the Maven phase into my Docker, my container. But the problem is, generally speaking, it takes longer to build the artifact in containers compared to local machine. And we can argue and we can discuss that we can achieve near-time local performance while working with containers, but this takes a lot of time, and it needs to add a lot of tweaks to achieve that. We use fat jars, and by fat jars, we put everything the application needs into one jar. And that's meaning all the dependencies, all the static resources, and all the code that we modify. But the thing is, the part that keeps changing and that frequently changes is only the code. So we don't need to generate all those 3 things into the fat jar, which results in modifying the layer and wasting a lot of time in the build phase. And there are a couple of issues while using the Docker current builder. So with the Docker current builder, we can't execute commands in Dockerfile in parallel. So we can only execute them in sequence. There are some caching issues, as I've mentioned in the demo. So because of these false dependencies, if we change it one layer, all the layers that comes afterward need to be rebuilt and re-executed in order to generate the image. For security reasons, historically, there is no volume support in the Docker build command, and there is no safe way to access the private assets. And there is kind of a solution or a hack to build our artifact using Docker, which is to use a Docker run and bind and mount our local repository with the container repository. But this has a drawback: it pollutes our local repository with a lot of root owned files, which drive our development crazy. And Java is 20 plus years of tools and community building a lot of nice stuff. And if we think about the war promise that Java comes with, which is write once, deploy, run anywhere, we see that the PODA promise that containers comes with, which is package once, deploy anywhere, it takes the WORA promise a bit further. And the ideal scenario for us, the Java developers, is if we can use the same good old tools that we are familiar with to build our artifact, like Maven and Gradle, to generate this new unit of deployment, which are containers. And luckily, many tools exist, and my talk today will highlight one tool of them, which is Google JIB. So JIB is a pure Java plugin, open source from Google, and it's available in both Maven and Gradle. And it enables us to build Docker images without the need of a Dockerfile and without the need of a Docker daemon installed in our machine. So what JIB basically do is something similar to this Dockerfile. So JIB doesn't need any Dockerfile to run to build the image, but if we imagine that JIB uses a Dockerfile, it will look similarly like this. So since JIB is a Java plugin, it understands somehow our application, and it splits it into multiple layers, putting the files that are least likely to change at the top, like the dependencies and the resources file, and the files that are more likely to change at the bottom, which are our source code. This enables JIB to speed up the build process, and also it enables to ensure reproducibility, since if the code does not change, the generated image will be exactly the same. So I have another small demo here, which is the exact same demo, but this time I'm not using Dockerfile. I'm using the JIB plugin for Maven, which is this one, and I'm adding some configuration. So whatever configuration you need to customize your image, it will be available here. And I'm just basically telling JIB where to push my image, and using Google Credential Helper for the GCR, for Google Cloud Registry to connect, which basically I'm telling JIB to use the Credential Helper from Google to connect to my registry. And then binding here the build goal from JIB with the package. So whenever I run the build mvn clean package, it will automatically run JIB. So if I change my directory and go to JIB and then run the package step, so this will run the same way you are familiar with. And finally, you will see now that JIB is building our image and then pushing it into the registry. So now it's the push step, and we have generated an image without the need of a Docker daemon and without the need of a Dockerfile. And if we check the target, which Maven keep basically its local cache files in, we can see that another directory has been added, which is JIB cache. And in JIB cache, we have a layers folder that contains kind of similar layers, the layers that Docker do, and they are basically some tar files that contains the files needed to build the final image. And you can verify the content of those tars by executing the tar command, target, okay, JIB cache, and the layers, and then you can choose whatever. Let's choose this second one. Okay, let's choose the third one. And you can see that this one contains all the dependencies needed by my application. And if you can see here, you can see all the dependencies. So basically, JIB do the similar things as the Docker builder command does. And you can verify, another way to verify what JIB does is using the dive command. So if you're not familiar with the dive command, it basically enables you to verify or compare the layers, verifying, it's a command line tool that compare the layers, verifying each layer, what files it added and what files it removed. So JIB as a base image use another project from Google, which is Distroless container images. And very briefly, these projects enable to build container images that are very small. So the base image, those images are built using Google Bazel. So all those images are basically generated from Bazel, and it's a lightweight Linux distribution. Its size is very small. It's a glibc based, and here we see that we added the GDK. That's all generated by the Distroless project, and then we have So first, let me reduce those two. And then if we see that this one, JIB, in this step, in this layer, JIB added the resources. And here, the first step, this one, JIB added the libs. And this one added the resources. And the final layer is adding our class files, the code that we modify. So basically, when we change the code, what helps JIB to be really speedy, it's when we change the code, only the last layer is modified and not the whole thing. So that was quickly JIB, but there are other builds. I mentioned it here. There are other goals. I mentioned here the build goal, which enables you to generate image without the need of a Docker daemon. You can use the Docker build goal, which needs Docker, which generates an image, and there you can load it with, which calls Docker to generate the image. And finally, you can use the build tar goal, which build a tar, and then you can load it into the Docker daemon to use the image. So you can, with JIB, you can generate both Docker images and OCI images. JIB is configurable, is pluggable. You can have a lot of options in the configuration section, as I've mentioned it, to customize your image. By default, JIB use as a base image Distroless Java image, but you can specify whatever base image you want to use. You can customize your runtime with JVM flags and environment variables, and you can even add some directories to customize your image. So with JIB, we succeeded to reduce the steps from 5 to 3, but we still need to deploy manually the generated image into my Kubernetes cluster. So can we do better? Yes, we need to find a way to simplify the deployment and continuously deploy the application to our Kubernetes cluster. And for that, there is another tool from Google also. It's called Skaffold. And Skaffold is a command line tool that you need to install in your machine. It comes with a lot of commands. But it basically handles the workflow for building, pushing, and deploying your application into your Kubernetes cluster. So if I go back to my small demo here, you could see that I have a Skaffold YAML file. And as every cloud-native tool these days, it needs a YAML file to be configured. So if you hit like YAML files, I'm sorry for you. And so basically, the configuration file contains some steps. And here I'm using only 2 steps, the build phase or the build step, and telling Skaffold where to generate the image, where to push it, and how to generate it by using JIB. And how to deploy, the second step is how to deploy into my Kubernetes cluster, and I'm simply using kubectl. So to run the application into my cluster, I simply run one command. So JIB comes with a lot of commands, and maybe after the talk you can have the time to check them all, but the command that will change your life is basically Skaffold dev. So what basically this command does is it builds the image, push it into a registry if needed, deploy it into your Kubernetes cluster, it print the logs from your application or from your pod. And if we check our application, you could see here that the application is working perfectly. How about if I make some new changes to my application? So instead of hello world, I again does hello devox. So once I hit command save, JIB automatically detects the changes, or deploy my application into my Kubernetes cluster, print the logs for me, and I can easy peasy verify. Okay, so easy verify the changes that I wrote into my application. Yeah, so that was Skaffold. Let me quickly, okay, nothing, perfect. So yeah, so Skaffold enable you to continuously deploy your application into your Kubernetes cluster, either remote or locally. So it enables you to, it handles everything from detecting the code changes, building your image, tagging it, pushing it into your registry, and then continuously deploy it into your Kubernetes cluster. So yeah, with JIB and Skaffold, we succeeded to reduce the changes into one step, and this step is at the very beginning, which is running Skaffold dev, and then verifying the changes and enjoying the changes deployed automatically and continuously into our Kubernetes cluster. But there is another problem, which is YAML files. And in Kubernetes, YAML files are tied to a specific environment and a specific version. So you maybe have your local environment, development environment, and you will have a remote cluster where with your team a remote development environment cluster, and you maybe have like some staging, maybe production. And the thing is, you need to maintain the files for each environment and for each version. And the other thing is, 90% of those files are exactly the same. So you add only some minor changes between each environment. So we need some way to customize the deployment between each environment. And for that, there are many tools, and I will talk very briefly for the rest of this talk about two tools. The first one is Helm. So Helm is more than a templating tool for Kubernetes, and is an application manager for Kubernetes application. And it's composed basically of two parts. So with this talk, there is another talk about Helm running in another tools in action running, talking about Helm. So very briefly, Helm is composed of two parts. The first one is a Helm client, which you will mostly interact with. And the second one is the tiler, which is the server part installed with your Kubernetes cluster, which enables you to make the magic and deploy them into your Kubernetes cluster. And if you ever worked with Tyler or with Helm generally, this is the part that will make you some headache while working with Helm. So application in Helm are called charts, and you can make your own charts or choose or use the ones that developed and produced by the community. So you can depend on other charts. You can deploy multiple versions of the same chart. And the part that really interests us is the configuration over values. So if I go back to my small demo here, you could see that I have another part of the deployment is using Helm. So basically, in Skaffold support Helm, and I need only to mention where to find the chart path. So the chart path looks something like this. So I have the templates, which are basically contains the same configuration I had with previously, but this time it contains variables. So this is what we call configuration over values. So Helm enables us to add variables to our YAML files, and then for each environment and each version, define the values of those variables. So Helm basically, for each specific environment, will take the good value and put it into the Helm and generate the correct YAML file and deploy it into our Kubernetes cluster. So that's basically it. So once I change the application, when I press enter save, so Skaffold okay, so if I run Skaffold again, normally you should see that to deploy my application, I no longer need I'm no longer using kubectl, but instead I'm using Helm, which is like this whole part. So Skaffold supports Helm as well, and it supports another tool, which is Kustomize. So Kustomize took a different approach. It's a templating tool, but it took a different approach. So instead of adding variables to YAML file, it basically use a declarative configuration management. So we use plain YAMLs to configure our deployment, our config files depending on each environment. And basically, we will have the base folder that contains all the dependencies, or all the files needed for that are common between all the environments. And then we will have some overlays. And those overlays are basically the changes that are specific to each and every environment. So the merge of those two files, of those two folders, will give us the final YAML file that will be deployed into our Kubernetes cluster. And Kustomize is now integrated with the kubectl command, so it's kind of the default templating tool now in Kubernetes. My final demo is using Kustomize, but I wanted to show and highlight that to highlight that Skaffold is not for hello world application. We can use it even for real world microservice application. So here I have the pit store from Micronaut application, from Micronaut project. I have a lot of microservices, all written in using Micronaut framework, but some are written in Groovy and some are written in Java, and I have even a React front end, which is this one. And I'm using Skaffold with all the configuration, and I have in a lot of artifacts. And in the artifact, I defined where I'm telling Skaffold where to deploy each image, and for the deployment, I'm using Kustomize. So if we look at our Kubernetes files, we'll see the base image, which are basically the common files for all the environments, and then we will have specific folder for each environment. So for my local environment, I'm simply adding a common label for all my pods and all my containers, which is group pit store. So I already run the Skaffold for this application, and I wanted to highlight one final feature of Skaffold, which is file synchronization. So we already saw how Skaffold build images using JIB, but if you are using a framework that supports hot reloading, like in React, so the application looks something like this. It's basically a simple application. It's a pit store application. And you could see here that I have check our popular pits, right? So in development, while using React, they have this feature of hot reloading. And I started the container of my front-end application using the Dockerfile, this one. So I'm using a run start, which is support hot reloading in development mode. So if I change the files, okay, so the home.js, and I added checkout popular pits at Devox. So there are no generation of image, no building. It's simply synchronize the file between my local development files in the containers, and the changes are deployed kind of real time. So that was Skaffold and JIB and Helm and Kustomize. So Skaffold is pluggable, it's customizable. It handles all the workflow from detecting changes and deploying them into your local or remote clusters. And with that, I have another 3 minutes if you have any questions. Yeah, don't be shy. Is there any questions? Yeah.
Do you need is it possible to run with the local repository of your containers, or do you need a remote repository?
Well, so the question was, can you use a local repository? So what do you mean by a local repository? You mean the one that comes with Docker, like saving it in your local machine? Or yeah, with JIB, so JIB need a registry. So it could be like whatever your registry is, you can connect to it and deploy and push your images to it. So if you need to save your images locally, the same case we do while using Docker, so you have to use the Docker build goal instead of using the second one. So the Docker build tool basically makes a call to Docker to save the image and to build the image and to save it into locally. So we can use it locally. Because JIB doesn't use Docker with the build goal, so it needs a place to save the image, which is generally a registry in some place in the internet. Another question? Yes?
How does JIB work when you have, let's say, a multi-module project? You have common dependencies which change in the same time as your application.
So basically, it works the same way you generate your jar file. So the question was, how does JIB work with multi Maven modules or Gradle modules? So basically, you need to grab those dependencies. So I suspect those other modules are basically dependencies into your files. So Maven will compile your application, will generate your dependencies, and those dependencies will be generated the same way, put it into the dependencies folder into your image. If you have, as the last demo I have shown, a multi-module that is one generates an image, so then you simply need to declare a multi-module in your Maven, and then each one will generate its own image. Any other question? 1 minute left, and it's time's up. Thank you for your time, and if you have any question, please, I'll be around. Thank you.